Hi everyone, welcome to Schools Not Out,
your daily classroom for CSEC and CAPE students. Today's lesson is CSEC Math. And guys, we'll be talking about trigonometric ratios, angles of elevation, angles of depression.
I am Nikisha Hardy.
And I am yours truly, Donald Burrell.
Today we're going to be looking at how we will apply these ratios to solve problems that involve angles of elevation and depression. However, before we get into angles of elevation and depression, we'll do a quick review of the trigonometric ratios.
Okay, so as was stated before, at the end of today's lesson, you will be able to use trigonometric ratios to solve problems. You will also be able to identify angles of elevation and depression, and we'll be able to represent and solve problems involving angles of elevation and angles of depression.
So let's first begin by looking at the right triangle. So, the right triangle is a type of triangle that has one right angle and two acute angles.
As you can see on screen, we have an image or an illustration of our right triangle. In our right triangle, our right angle is represented by the little square box on the left bottom corner of our triangle, and the two acute angles are represented by the angles outlined.
Before you go any further, Burrell, could you remind me what are acute angles?
Acute angles are angles that are less than 90 degrees.
Okay. Now, let us do a quick review. Can you tell me which of the following is a right triangle based on what we said earlier?
Make so much person, I'll get it right.
Is it A?
Let me say all those who say A.
All right. So A is not a right triangle. Why though?
Well, when I look at this, it almost looks like a right angle triangle, but it is missing the representation of the right angle.
Okay.
Now, if the measure 90 degrees is not there, or the representation, which is this little, the square box.
Oh, this one
yes,
here? Yes.
Is not there in the diagram, then we cannot assume that it is 90 degrees.
Okay.
Because if it is 89.99999999999,
okay,
it will look like 90. But it is really not 90 degrees. So it is not a right angle triangle.
And we have to be precise in mathematics.
Absolutely precise.
All right, what about this one?
I think we kind of gave it away already.
True. Yes. And C. Correct.
Did you all get it correct at home? We hope so.
All right, let's continue. So, the right triangle has three named sides. They are the hypotenuse. Now, that side, the hypotenuse is a diagonal side that faces the right angle. It is the longest side of the triangle. Then we have another named side, which is the opposite. The opposite is the side facing the working angle. The working angle is outlined by the letters A and the letters B. So remember guys, our opposite is always facing the working angle, and we demonstrate this. The opposite is facing the working angle here, and in our second triangle, where we have the angle B, which is our working angle, the opposite is now facing B. So basically, we can see that our working angle can be at different orientation then. So, or depending on the orientation of our right angle, the working angle can be in different positions.
Yes, which means the opposite will not necessarily always be in the same side for each triangle that we will be looking at.
Okay, got you. Now the next named side is the adjacent. Now we know the word adjacent means what? Beside. So this is a side that forms a working angle along with the hypotenuse.
And here, we are now labeling our adjacent. And as you can see, in both our triangles, the adjacent is alongside the angle, or it is now forming the angle with the working angles.
Yes.
So, in summary, as you can see, it depends on the orientation of the right triangle, the different sides, and also the working angle. The sides will change. But will the hypotenuse change?
You know, that's what I was looking at a while ago in Aniki. When I looked at it, I realized that the hypotenuse is always just one side. It's always facing the right angle.
And remember, it's the longest side of the triangle.
So I guess if I'm looking at a problem, that is a right triangle problem, I can start by identifying my hypotenuse first because we always know where it is, right?
Definitely.
Sweet. Okay, so in the CSEC syllabus, we explore three trigonometric ratios. There are sine, cosine, and tangent. These trigonometric ratios are abbreviated as SIN for sine, COS for cos, and TAN for tan.
Tangent.
For tangent. We'll now be looking at these ratios.
So the first one up is sine. So looking at the right triangle, sine is showing the relationship of the working angle with the named sides. Now on this right triangle, we're seeing opposites, the side that is opposite to the named triangle and the hypotenuse. So when we're working with the trig ratio sine, identify the working angle first of all, and then find the opposite side to the working angle and then the hypotenuse of the triangle. And then these will show the ratio, as you can see, of sine. And you also see it is abbreviated SOH, the S representing sine, and O for opposite, and H hypotenuse.
Nice little abbreviation there. All right. Now, the next trigonometric ratio is cosine. And the cosine gives us the relationship between our working angle and the ratio between the adjacent and the hypotenuse. Now, as you can see, it is demonstrated as, or illustrated as, the cosine of an angle, x, is equal to the ratio of the adjacent side divided by our hypotenuse. So as was said by our colleagues before, when working our problem, it's always good to identify the sides that we're working with, extract that information from the problem, and then substitute it into our problem. So in this instance, we would identify our adjacent first, we would extract the length of that side, we would identify our hypotenuse, identify the length on that side, and then we substitute it in our problem. And as you can see, it is abbreviated CAH.
Very good. And the other one that we'll be looking at is tangent. So the tangent of x here is showing the relationship, the ratio between the opposite side and the adjacent side. So as you can see, the opposite side is being divided by the length of the adjacent side. And that is abbreviated TOA. So T for tangent and O for opposite, A for adjacent. Now,
Yeah, you hear the song coming up
yes,
now, don't it?
Yes. Now, you might be wondering, how can I remember so much information? No, songs can help us with that. So we have a little tune to this SOCATOA abbreviation.
SOCATOA.
SOCATOA. SOCATOA.
So, we finished already?
Yes.
No, that was nice. That was nice.
Yes, it
we have
was.
to do that again at the end of the show.
Definitely.
Cool.
So, moving on. Now, in using these ratios, the calculator is very important, and not just any old calculator, you know. It's a scientific calculator that we have to be using. So, when you have the scientific calculator, there are many buttons on them. So we have to familiarize ourselves. I know you already know, but let us just review what the key buttons that we'll be needing to work with the trigonometric ratio.
All right. So on our scientific calculator, remember, we're working with trig ratios. And we said something that was extremely important before now, guys. Remember, we said that our sine is represented by SIN, or cosine is represented by COS, and Our tangent is represented by TAN. Now, these abbreviations are exactly what you'll be seeing on your calculator when you're looking for these trigonometric ratios. So, when we want to work problems with our trig ratios, for short, we are looking for abbreviations SIN for sine, COS for cos, and TAN for tan.
So let us do a quick practice, quick run.
Before we do the quick run,
Uh-huh.
something just occurred to me.
What?
Persons have different types of calculator, different brands of calculator. They all work the same way?
Well, we will always see this, the abbreviation sine and cos on them, yes.
Okay.
But as you said, different brands, they will operate differently. So some of them you may have to
Enter the number first.
enter the number, the size of the angle first, and then
the trigonometric ratio that we're looking for.
or you'd have to enter the trig ratio first and then the size of the angle.
So guys, if you're using your calculator and you realize that you enter the number and then select the trigonometric ratio and nothing happens, don't be worried. Just try it the other way around.
Yes.
Enter the trigonometric ratio first and then the measure of the angle. Something will happen, I promise. So now, we are going to look at some trigonometric ratios. All right, so I hope you have your calculators at home ready for me, because we are going to be looking at these and we're going to be doing them together. The first up is sine 30.
So you can press sine on your calculator and then enter 30 or the reverse.
The second is tan 45. I hope you write down the first answer, by the way. You know. The second is tan 45. So you may want to try 45 degrees and then tan. And remember, if that doesn't work, try the other way around. And then cosine of 60. Let's see if you guys got it correct. Did you guys get these values at home?
I hope you did.
Great.
So now let's apply the trig ratio to a problem. So here we have a situation. A 55-meter wire connects a point on the ground to the top of a pole. The cable makes an angle of 60 degrees with the ground. Assuming that the pole is perpendicular to the ground, find the height of the pole to the nearest meter.
All right, so let's see what that looks like.
So it's best remember when we're solving problems, when we understand the problem, we make a representation so we can see what we need to do. So here we have a representation of the information in the problem.
All right, so let's see what we're working with here. We're given an angle, 60 degrees, and I realize that we want the length of the pole, and the pole is opposite to my working angle, which means we're working with an opposite side. We are giving the measure of the length of the wire. So the length of the wire, that is our hypotenuse, which means we're working with hypotenuse and opposite.
And opposite.
Which one is that again? Which one is that again? Sine.
Yes.
Good. So we're looking for the sine equation. And it is read, the sine of the angle x is equal to the opposite over the adjacent. Now remember, in this particular problem, we wanted the length of the pole, so we don't know what the opposite side is. We know that the measure of the angle is 60, the length of the hypotenuse or the wire is 55, so we can just put that information, as I say, represented on screen. So let's see what that gives us. We now transpose, because remember, we want to make the opposite the subject of the equation. So we transpose, and here we have that the opposite side, which is representing our pole, or the length of the pole, is now the subject of the equation. We can now simplify this to get 47.6 meters. So the length of our pole is 47.6 meters. And remember, guys, it's always good to write this out. The length of the pole is 47.6 meters. Don't forget our units. It's not correct without the units, guys.
Yes. Go ahead.
Okay, so now we're going to be looking at inverse trigonometric ratios. Now, before, in the problem that we worked before, we were finding the length of any one of the sides in the right triangle. What if we wanted to find the angle? We would use inverse trigonometric ratios to find the angle that we want to use in our problem. So the inverse trigonometric ratios are represented by the following.
Right. So on your calculator, you will see sine in raised to the power of -1. So on the calculator itself, before we were using the buttons, and now we're looking directly on the calculator.
Yes.
So that's what we're going to apply. Now to get to these functions, we'll have to use, some of your calculator might have second function or shift. So this button, this function button, will take us to the inverse of sine and inverse of tan and the inverse of cosine. So when we want the inverse, that is to find an angle, we'll have to select second function or shift on our calculator before we enter the size of the app.
And remember guys, even though it's different calculators and second and shift are looking a little bit different, they do the exact same thing.
Go ahead.
All right. So let's look at an example where we're going to use an inverse trig function now.
Yes.
So in this example, we have a ladder that is leaned against a wall. We are told that the base of the ladder is 2.5 meters away from the wall and the ladder is 5 meters long. We are asked what is the angle between the ladder and the wall.
Yes.
Let's see what this looks like.
So again, we need to look at the information that is given, what we have, and then identify which ratio would be suitable to solve this problem.
Okay, so I'm looking at this problem and I recognize that we're again using an opposite side and we are again using the hypotenuse. So it would be sine. But we're looking for the inverse, so it's going to be
right.
Sine inverse that we will be ended up using.
So remember, anytime you're trying to find an angle, we use the inverse of the trigonometric ratio.
But we always have to start out with the actual sine function itself.
Yes.
All right, so we start with our sine function. And of course, we input the data we extract the data from the problem. So we know that the opposite is 2.5 meters. The hypotenuse is 5, we put that in there. We simplify it to get a half. And now we're going to use our sine function to find what the ratio is congruent with an angle, or how congruent it is with an angle.
So you would be selecting second function or shift, then you either press the sine button and then 0.5 to get the size of your angle. And remember, you have to put on degrees to know that it's an angle.
Yes. So as you can see, our result is sine 30. Sorry, not sine 30.
30 degrees.
Good.
So let's get into the meat of the matter, where we are applying the trig ratios to find angles of elevation and depression. So imagine that you are standing a distance away from your cat who is on the kitchen floor. So you're in your kitchen and you're standing a little distance away. The cat is on the floor. As you look down at the cat, imagine a diagonal line is formed from your eyes to the cat.
Now, let us see what that looks like. Again, remember, with all these problems, it's always good to illustrate what we are looking at.
Yes.
So the illustration is, as you can see, I think I look good right there.
Yeah, you look, so if that is you, what is that?
Your cat, my cat.
Okay.
Good. So, this is now the line that is formed from my eyes to my cat's eyes.
Yes. And that is called your line of sight. So the line of sight, or the imaginary line that is formed between your eye and your cat, is called the line of sight. Bear that in mind.
So if we want to put it formally, we can say that the line of sight is the line from the observer's eyes to some other point.
All right. Now, ponder this. What if you are now standing on the same spot, looking out of your kitchen window,
Okay.
and you see someone coming towards you?
Okay.
Would your line of sight change?
Well, so I'm looking at my cat and I was looking down. I am now looking through my kitchen window.
Yes.
And I am seeing someone. Oh no, my line of sight would change.
Definitely.
Because now my line of sight is going to be
horizontal.
Okay.
Yes.
Sweet.
So remember, we have now established our line of sight and our horizontal line. So bear those in mind.
So now we're going to be comparing our horizontal line with that line of sight, and we say it gives us what we call an angle of depression. And the angle of depression is really that angle that is formed between the line of sight and the horizontal line looking down. So this is called what we call the angle of depression. And let me just illustrate that here. So in our example here, we see that I am looking fabulous.
Yes.
And looking at my cat. My cat, I think, is probably hungry. He's looking up at me.
Yes.
And there's my line of sight. There's that horizontal line that we spoke about. And the angle that is formed between our line of sight and the horizontal line, which is parallel to the ground, that is what we call our angle of depression.
And it's good to note that our horizontal line, we normally look out. So it's always there. It only changes when we look up or down. But normally, we're looking out.
So, who can tell me what an angle of elevation is? No, I think I put it up on screen.
Yeah.
So let's just tell them anyways. The angle of elevation is formed between the line of sight and the horizontal straight line looking up.
But before you bring up that, take it back down quickly. So since we were, the angle of depression is when we are looking down at the cat. It therefore means that the angle of elevation would be what? What would that look like?
When the cat looking back at me?
Ah, yes.
So the cat would now be the observer and I would become the point.
The spot on the ground.
So there's that picture. This is my very hungry cat looking up at me, and I'm not going to feed him until the next 30 minutes when I get off here. So this angle that is formed between the horizontal line, which is parallel again to the ground, and my line of sight, or my cat's line of sight,
yes,
that angle is what we call the angle of elevation.
Yes. Now, what do you notice? What do you notice about the angles that are formed here? What is wrong with you? What?
It looks like a Z.
Oh, definitely. Yes, it does look like a Z. And thinking back to previous lessons, where what this is, and thinking about different types of angles. Yes, Warren, go ahead.
I remember
yes,
that when we have parallel lines and a horizontal line or a diagonal line, it forms a Z, and the Z represents what we call alternate interior angles. Yes.
Because we would have the go ahead. We would have the angle of depression being formed and the angle of elevation being formed. And what we know about alternate interior angles?
They're always equal every single day and twice on Sundays.
And therefore what that means?
Our angle of elevation is always equal to our angle of depression.
Ah, beautiful. So, let's continue. Now, remember, we're solving problems that requires the trigonometric ratios. So, therefore, means that we have to apply some problem-solving skills. And we've been doing that previously, but I just want to highlight them quickly. So, first step, understand the problem. That is, read the question, try to understand what it is asking you to do, what is required to do. Then step 2, make a sketch. I mean, for the visual learners, this is important, and even for the ones who are not so visual. But making a sketch, and if you realize throughout the lesson coming down so far, our sketch is usually a right triangle for these problems. And then carry out the plan. So we're going to choose the appropriate trig ratio and apply it. All right, and then we check to make sure our answer is correct. So remember these steps as we go forward in solving these problems.
All right, so let's see if we can look at an actual angle of elevation and depression problem.
Or, yeah.
So here, I said that I'm 2 meters tall. I think I'm a very tall and handsome guy.
Yes,
I am 2 meters tall. And as we said earlier, I'm standing a distance away from my cat, but that distance is 3 meters. I am now going to tell you what my angle of depression is from my cat, from my eyes to my cat.
We're going to try and find out what that is. So let's remember, make a sketch.
So let's see what that looks like.
Good. So we have that. And the question asks us for the angle of depression. So based on what we have, what are the sides that we have?
All right. So I'm looking at this, and this angle, this side, with 2 meters, seems to be the opposite side, and the side with the 3 meters seems to be the adjacent side.
Yes,
Good.
yes.
And opposite, so katoa.
So we're looking for opposite and adjacent.
Tan.
Tangent,
Good.
yes.
So we're going to use our tan formula to see if we can find our angle of depression. So here, nicely laid out for you, is
Yes.
our tan. So the tan of the angle, or tangent of the angle B, is equal to our opposite side. And remember, our opposite is now equal to
2 meters.
and our adjacent is equal to
3 meters.
We put that information into the formula, okay?
Yes, substitute.
Now we're going to, or we substitute, that's the more appropriate word. We substitute them into our formula. After which we're now going to reduce this ratio. So we're going to simplify it.
Divide.
So we're going to divide our 2 meters by our 3 meters to get a result of 0.666.
Now, when we get to this point, remember we're trying to find what? The angle. So what we have here is we need to change this now to degrees to get the angle. So when we remember, what do we do when we want to find an angle?
Me.
You again, Borel.
Yes.
All right.
Good. So when we want to find the angle,
Yes.
we are going to use our trig ratio. No. We are going to use our inverse trig function every single day and twice on Sundays. Good. So at this point, we're now going to use our trig ratio
The tan
that
inverse.
corresponds with, or trig inverse that corresponds with tangent, and that would be tan inverse. Now remember, this is represented by tan to the power of -1 on any calculator that is out there.
Yes. We
Good.
just need to press shift or second function to reach to that.
Good. So now we have tan inverse of 0.666, and if you notice, we have it at 666 because what we want to do, we want to have as many numbers in the decimal place to work the angle so that we round our final answer. We try not to round while working the problem. We try to round after we've finished the problem. So here, this star represents that the 666 continues. When we reduce this, we get an angle of 41.8 degrees.
Don't forget your degrees.
Okay. So, let us just review some of the things that we've learned so far in this segment.
Yes.
We've learned that right angles, right triangles are only right triangles if the measure is there, right?
Yes.
Or if the rectangular box is there to signify that it is
A right
angle.
Right triangle, yes.
We also learned that there are 3 named sides on the right triangle, which are
The hypotenuse, the longest side, the adjacent side, that is to the working angle, and the opposite side
yes,
to the working angle.
good. And our trigonometric ratios are sine, which is abbreviated by SIN. We have cos, which represents, or the abbreviation of cosine, and we also have tan, which is the abbreviation for tangent.
Yes, and we also learned that we can also use the inverse of these ratios to find angles.
And those angles are our angles of elevation and our depression. So we looked at a lot of information before, and we are now going to see if we can use this information and apply it to an actual problem.
CSEC problem.
Now in this problem, it says we have a diagram, and the diagram is not drawn to scale. In the diagram, it shows the position of 2 ships which are represented by P and Q at an anchor. FT is the vertical face of the cliff jutting out of the water. P and Q are 180 meters apart. FT is 80 meters and the angle FPT is 40 degrees. Okay, the first question that we're asked is to determine the angle of elevation of P from T. And before we begin our problem, as we said, it is always good to begin illustrating your problem. To see what exactly it is we are looking at, we can then take information from our problem, and then the extracted information we can now substitute in our equations.
Yes.
So let's go by starting our diagram. So we will begin our solution by first drawing our diagram. And I'm just going to draw my diagram here. All right. So I'm now going to put in my labels as it is on the problem. So
we have
this would be 118 meters.
And 40 degrees
40
at P.
degrees.
At P.
Let me just get this a little bit better. 40 degrees. And then we have
80 meters.
80 meters.
Yes.
Okay, great. Now I feel comfortable beginning my problem. So the first thing that I asked is for the angle of elevation. Now, when I look at my diagram, I can see straight off the bat that angle of elevation is actually already given. And elevation is, the angle of elevation is actually 40 degrees. So I can just write that my angle of elevation is 40 degrees.
So the second question is asking us for the length of FP.
Good.
So let's first identify where FP is.
So I'm looking at my diagram and I realize that FP is just a part of the whole triangle that we're given.
Yes.
So I'm now going to extract the triangle that would have FP in my solution. So I'm going to extract triangle TFP. So this is T, this is F, P, and the angle of elevation that we were given before is 40 degrees.
And the length of FT
Is 80 meters. Now, when I look at this, I realize that the working angle is opposite to 80 meters, and I want to find the length of FP. Now, given that the line TF, which is 80 meters, is opposite to the working angle, we know that the opposite is one of the sides that we're working with. FP is adjacent to the angle or beside the angle, so automatically we know that it's the adjacent side. Now remember, when we have opposite and we have adjacent, it means we're going to be using
opposite and adjacent. So that would be tangent.
Good.
Yes, yes.
So we say that the tangent of our angle is equal to our opposite
divided by
our
adjacent,
which
is FP.
So remember, our opposite is TF, which is equal to 80.
So let's substitute those values into the equation.
80 meters
divided by the adjacent, which we don't know, FP.
Good. And
the
our
angle
is
40 degrees.
Good. I feel more confident now. I see my answer. And since I want to find FP, it means that I am going to make FP the subject of my equation now.
Yes.
So I'm now going to transpose FP to get
So as you're working there, students, you realize that when we're solving problems in math, we are drawing on other concepts that we have learned prior in order to solve a current problem. So the concepts are interrelated. So now we're drawing on what we call it again, Borrell?
the trigonometric ratios?
No, where we
Transposing?
we transpose. So we would have learned that prior. So remember, it's not, the concepts are not isolated. Always think about what you have learned before that can be used now to help you in solving the current problem. So when we do tan 40 on our calculator, we would get 0.8.
So this is 0.84.
Yes.
FP is equal to 80 meters. We still haven't found FP as it. We are going to have to transpose again. We're going to have to transpose again.
Yes.
So we're going to now transpose this 0.84 to have FP
truly become the subject of our equation, which is going to be equal to 80 meters divided by 0.84.
So how did we get FP to be by itself on this side? What operation did we use?
Well, when we are transposing, it's always the opposite or the inverse operation that we use.
Yes.
So the reverse operation for multiply is divide.
Yes.
So if I transpose,
Do the
I divide
Yes.
both sides by 0.84 and 0.84 here. So let us put it here. So let us say I actually had 0.84 here. I would actually be dividing both sides by 0.84.
Good.
The 0.84s would cancel, leaving me with FP, which would be equal to 80 meters divided by 0.84, which gives me a result of 95.24 meters. And remember, guys, our units are very important.
Yes.
Now we're going to just insert this on our diagram. This answer for FP, so the length of FP is 95.24 meters. Okay, so what did our third part of the question say? We are to calculate now the angle of elevation
Step back to read it.
of
Q from T.
Okay, good. So I need the space here, so I'm just going to erase what's here. And we realize that we're going to calculate the angle of elevation at the point
Q. Yes.
Q.
Yes.
Which means I am going to be using this entire triangle here. So let me draw another representation of what it is that I am going to be doing. So it's going to be T. And we're recognizing something here. If we're going to be using the entire triangle, we are now going to have to calculate the total of FQ,
yes.
which is
95.24. So we would add it to, so we'd have to add this length to this length to get the full length of FP, and that would give us, what,
13.24?
Yes. Yes.
And if you notice, I am always writing on both sides of the equation 24 meters, and this is going to be 118 meters, and that gives us a sum of 213.24 meters.
Yes.
Again, I realize that it is a situation where we have the opposite side. We have the opposite side,
yes,
and we again have our adjacent. So we know that we're going to be using our tangent formula again.
Yes.
So to work this problem, it's going to be the tangent of the angle that we don't know, that is equal to the opposite side divided by the adjacent side. So here, we know that our opposite is 80 meters, and our adjacent is 213.24 meters. So the tangent of that angle is equal to 80 divided by 213.24, and that gives us
20 points.
A ratio of 0.3756. Now remember, we want the angle, so we're not going to have to use our inverse trig function. So it's the inverse trig function that corresponds with tangent, which is tan inverse of 0.3756. And this gives us an angle of 20.56 degrees. Whoa, that was a lot. Woof.
Yes, it was.
Long.
And because you're working for your points here. And students, I love how he took out the triangles and took it piece by piece to see clearly what we are looking at. Remember, first he extracted a smaller triangle, one of the triangles. Instead of looking at everything all together, it makes it so much easier when we do it in small pieces. And that is quite helpful, I think. I hope you will practice this strategy while you're going forward in your mathematics practice.
Good.
Oh, Lord.
It was a long day.
Yes.
You think we can wrap up now, right?
I think we should.
All right, let's do a quick summary.
Okay. So, we looked at the right triangle.
Yes.
We looked at the trig ratios.
Yes.
We also looked at how to use a calculator.
Yeah, very important.
Very important, yes, to solve these problems. We also looked at the cat and the man. You remember that?
I am the man. It's the cat and I.
Yeah, so yes,
Okay.
sir. And we use that to look at what again?
Inverse trigonometric functions, angle of elevation, and angles of depression.
Yes. Oh, you know, I just remember our little song.
Soka-toa, soka-toa, soka. Why you always finish the song before me? It's like it's me alone enjoy this thing.
No, it's just that we have more things to do.
But that is all for today.